Milo. Milo, what's this? Come here. Come here. Come here. What is it? Say hello, Milo. We're live, Milo and I. He's my morning companion, huh? He always comes up here and lays with me when we do the live feed. Today we're talking about spark plugs again. And the reason for that is that the recent test that I did on spark plug gapping generated lots of comments, as you might imagine. And the reason for that is because people want to believe the thing that they want to believe. And they're holding, the guys that there's obviously thousands and thousands of people that are watching it. And none of those guys are making comments or a couple of them that do are saying, hey, yeah, this was a cool test. This was interesting. I thought it would have made a huge difference. I didn't think it was going to run. I didn't even think it would start. I didn't think it would jump the gap. All that's cool stuff. But there are people that, want it to be true and know that this is one of the things that they did. And the comment that I get the most often is about indexing. Okay, you've tried plug gap. Some of the guys have come to grips with, hey, plug gap really didn't show very much power. We had to take away a bunch of plug gap and then put a bunch of plug gap in for it to show some kind of power. In my opinion, having the plug gap correct versus having lots of plug gap and seeing a difference of maybe 2 horsepower on something that's making, 450 horsepower or whatever is really not that much. It's something though. And I was happy that we did get a gain. But the comments that I got before that were, oh yeah, if you do that, you could change the plug gap, you can get 10 or 20 horsepower or whatever. And then now it's the indexing thing. Well, if you did both of those, it was indexing. And then if you also did, well, you got to change the timing and the air fuel, because all these LSs want to run at 12.8. Again, that's why we go through the procedure of showing you that we run it at 13.0 and 12.5 and 12 and 11.5. And then when there's no difference in power when you change a big sweep, micromanaging the air fuel, for instance, doesn't do anything. Just like micromanaging the gap. I think that showing that we did this, put these big swings in it, showed that there's not a lot of power there. There's a little bit, but there's not big power gains to be had there. And then obviously we got a lot of comments about, oh yeah, but what about boost? I'm not going to try to run 100 gap on boost. This channel, if you've seen all of the boosted stuff, it's always like run 18 or 19 plug gap so it doesn't misfire. When you're talking about boost, you shouldn't be looking for 1 or 2 horsepower with plug gap. You should be looking 10 or 20 or 100 or 200 or 500 or whatever it is. Just make it so it doesn't misfire. And this is especially true on, we're kind of spoiled on most of the modern ignition systems, whether you're running a Coyote or a Hemi or an LS, especially if you have the ability to adjust the dwell like we do on the aftermarket ECUs and maybe on the factory ones too. I just don't know enough about those because I don't spend time with them. But if we can change the dwell time of the coil, we have individual coil, coil packs or individual coil on plug stuff. So we don't have to worry about a lot of the problems associated previously with other ignition systems, especially single coil ignition systems and a distributor. That's why we all ran, especially on boosted applications. I know on my Mustang, I did running a crane or an MSD, some sort of ignition amplifier, either a CD box or something. So we ran those and we got, more ignition energy. Quite honestly, I never tried changing plug gap when I installed an ignition amplifier to see if it did anything. We know from experience that if we talked about this yesterday, that there's a limit to how much gap you can put in if you have an insufficient ignition energy. There's a limit to how much plug gap you could put in. If you put more ignition energy, like an amplifier or something on, you can extend that. But then the question becomes, do you need to? Is it beneficial? I honestly think that you would see more of a change possibly in fuel mileage or emissions maybe. That would be interesting. I would like to see that test, like an SAE level of testing or an OEM level of testing to find out how much those things change with changes in plug gap. And I suspect that for the OEMs, that's probably why the thing that they were interested in most. They don't need to adjust plug gap for power at the OEM level because they they already have their power goal met with other things. And so my guess is when they start honing in on things, they're honing in on, trying to improve the fuel mileage of a big heavy truck, and or trying to improve the, change the emissions output. And they probably can do that with things like that. That being said, I'm still very interested in, like with this plug gap thing, and more so on the running 10,000s plug gap. I'd like to see if timing would change that. I honestly don't think that timing is going to change the 100 gap, but it's worth a test. I didn't adjust either one of those. We didn't see, in fact, I wanted to check that and see. I want to see if, I don't think that the plug gap had a substantial change in air fuel. So I want to verify that. There's a 10, there's 100. No, you're talking about like a 1/10 of an air fuel point, and at some points it was none. So that's like a run-to-run difference. Yeah, there's almost nothing. I mean, a 1/10 of an air fuel point change is not a realistic change. If you see a power change, you would normally see more than that. But that brings me to my next thing, is that I want to do more spark plug testing, because now I want to test the different kinds of spark plug, because people are throwing out all kinds of things. Oh yeah, when I did use a file and put a V groove in my thing, it makes more, and we want to try side gapping and surface gapping and all of the different kinds of idioms, plugs, iridium and platinum and quadridium, whatever the things are. We want to try the different types of plugs. We want to try the different kinds of gapping, like side gap and surface gap. I want to try that. We want to try also indexing the plug. And that's what today is about. So the poll for today. Oh, that kind of changed. That's interesting. Let's see. So should Richard test indexing plugs? Very simple poll for this morning. And by the way, this is our morning motivation. So get your projects done. This is one of the projects that I like to do. That, for me, the project for the spark plug thing is for me to go online and take a look at all the different kinds of weird plugs that are available. So if you guys know of any, please shout out and let me know. So should I test indexing spark plugs? Do you think that there will be power with indexing spark plugs? I know Dan has chimed in a few times on the testing that they've done at that sort of level and not really found anything from indexing plugs. I'm wondering if it's like other things, might be application specific. Could we find something with particular types of combustion chambers? The one that I put up in the thumbnail is, I think that's a 462 valve chamber. And is that one that might benefit from them? Does something that has these like swirl dams in them where they're trying to promote mixture motion, those kinds of things, is that beneficial? Where should we aim the spark plug? Where should it be indexed? Should we try a couple of index points? Should it aim toward the intake valve? Should it aim away from the intake valve toward the exhaust valve? Should it aim directly in the center of the chamber? Should we try multiple things like that? Is that going to do anything? It's just that's just a lot of testing, and so we'd have to go through a lot of permutations of the different thickness washers to get them indexed in the right spot. But it would be interesting to see. We'd have to also do a baseline test, basically, to see if stopping the engine and going through a spark plug change, just putting it back in without doing anything, even maybe just mixing the spark plugs up, putting plugs in different things. The other thing I'd like to do is I want to try the different materials and, you know, the iridium stuff that we talked about, but also copper core plugs. And guys are suggesting trying copper core wires and things like that. And there's lots of theories on it allowing the voltage to start at a lower, allowing the spark to start at a lower voltage. And so the spark would be weaker with the copper core kind of plug, and instead of allowing it to build up, you know, there's all kinds of this stuff happening. The other thing that people have talked about is they can see changes when you monitor this voltage on an oscilloscope and stuff. And you can definitely see changes, but the thing is, the change that you see there, if it is there, there's more spark intensity, there's more duration. There are the things that you would be able to visualize and data log on a scope with the ignition energy. But the thing is, even though that's there, how does that translate into power? That's why we tested the gap, because we could see a gap. We know that it is changing things, and we can talk about the theory of the things that it's changing, but what does that equate to? And also in our specific instance with the LS, we're, like I said, basically blessed with an overabundance of ignition energy. We don't have to worry about rise time. We got multiple coils. We got a bunch of ignition energy going from, because we can adjust the dwell on the coil up to 4 or 5 milliseconds if you want to go that high. We normally go 4.5. But we have an ignition system that will support way more cylinder pressure than we're running here. And so it's never at a loss for ignition energy, even going way out in plug gap. We would start to see those things come into play on a lesser ignition system, if you will. And so maybe application specific stuff, we would start to see that. And then that's where everybody starts going off down the cylinder pressure thing. Oh, but on a super high compression, quite honestly, on any NA motor with this LS ignition, you're not going to run into an issue. If we don't run into an issue at 1,500 horsepower or 1,300 foot-pounds of torque, you're not going to ever get there with any sort of naturally aspirated deal. So that's not an issue. But if you have your just regular distributor in your small block Chevy, and it's not even an HEI, and you don't have an ignition amplifier on it, and it's a point ignition, you're going to run into different kinds of problems related to ignition energy that you might see that you won't ever see, obviously, on an LS. We've checked that box. We don't have to worry about that running the testing on our engine dyno on an LS application, because that's never something that we worry about. Even on boosted applications where we just put the gap at 19 thousandths. Once I take a spark plug and set the gap at 19 thousandths, and that's why I continue just to run it there, 19, 20, 21, whatever. That's why I just continue to run it there when it's NA. So we saw 2 horsepower difference between that and having a big gap in it. It's not even worth playing with on a boosted application. So we just put the plug gap down, run it there. Then that way we know that we'll never run into misfire all the way up to and including the, triple the NA power output. So we don't have to worry about that. That's one of the reasons I like the LS. And the other things too, Coyotes are like that, and the Hemis are like that. And when we do have to worry about stuff like that when we run small block Chevys. Like when we were running Chad Reynolds 400 small block, and we put the Pro Charger on there with the distributor, we had to bring the plug gap way down. We had to put an ignition amplifier on it. We had to do all that stuff to get the thing to, kind of cooperate and make power at that boosted power level. Because we're talking, a little more than 1,000 horsepower with the Pro Charger that we ran on there. But with a distributor and I think we were running a digital 7 ignition amplifier in the engine dyno on that. And then some kind of, I might have been a blaster coil, I think, if I remember right. I think we tried to use the coil that he was going to be running in the station wagon while the motor was in there. So I think we tried to duplicate that, but it worked out pretty well. But so the question is on the poll. So we'll see how the poll is doing. Should I test indexing plugs? Is there going to be any power in indexing plugs? And if I do that, what should I test it on? Should I test it on? Would we be more apt to see something on indexing plugs on a small block Chevy? Or a small block Ford or a big block? Would we be more apt to see it on if we were going to do an LS? Because I have those, it's easy. Might we see something more on a set of 317 heads as opposed to the 706 heads, which have a really good chamber design and it's smaller? Would we see something on a bigger chamber, where it wants more timing? Is all that stuff going to come into play? So let me know what you guys think about that. But definitely go get your projects done. I wasn't able to paint my big block Chevy heads yesterday. I was hoping to. I want to make sure that I get that done while it's still fairly warm out during the day. And it still is here in California, still fairly warm during the day. Let's see. Project Farm did a pretty good test on spark plugs. It's worth watching. I like the Project Farm stuff. So let's see, my Car Farm guys are doing this. Let's see, what spark plugs do you like these days for a stock T2 motor? Autolite AR51s from stock to heavily modified. I saw a significant reduction in CO emissions with them, which means a more complete burn is happening, which translates into more power. He said, dude, the answer is right here. That's the thing. I would love, and see, the thing is, when people say stuff like that, I'm hoping that it's actually based on they put it on a sniffer. They ran it with one plug and then ran it through the sniffer and then put another plug in and ran it through the sniffer. My guess is that didn't happen. My guess is, because I got a lot of those comments too, where, hey, I did this kind of thing to the spark plug and it just felt a lot better. I'm like, well, did it? And how much is I felt it and I wanted to feel it, and how much can you feel? Can you feel like I wouldn't, on a 450 horsepower motor, I wouldn't be able to feel 2 horsepower. I wouldn't know what the difference is. And if you made one run and then made another run and the temperature was different, it might be 2 horsepower different just from a change in temperature. So that's why I tell them, look, I can't do it based on it feels better. It feels like it's got more torque, or it feels like it's snappier or whatever. I'm like, I love all that and I want it to be true. I just don't know what the numerical definition of snappier is. I need to have a value placed on that, and otherwise it just doesn't tell me anything. Let's see. Test everything. It keeps the armchair experts up to date. Yep. I've read the same thing. The poorly designed combustion chambers are aided with indexing plugs. That's what I was kind of thinking with, because when indexing, when the boomers were indexing spark plugs, they were doing it on much older, less efficient chamber designs, the fuely heads of the day. And then maybe even the fuely heads were probably had a better chamber design than like an 882 big chamber smog head, I would imagine. And so on the 2.2 question, which is interesting, I'm really curious to see, there's a dramatic difference in chamber design between a swirl head and a G head, the OG head. I'm going to call them OG heads from now on. There's definitely a difference in the chamber design. And so I want to see if does one want more or less timing, which I suspect is going to be the case. And then it will be interesting to see if maybe spark plug gap or style metallurgy has an effect on those things. And we'll hopefully be able to test that when we have the 2.2 up on the dyno. Just got here, test it, but don't think it'll show anything on a low horsepower build. So you think it will show something on a high horsepower build? Testing indexing plugs. Yes, to be interested to know if it was way back in the 70s and 80s. I think that's where it may have been more effective. Is the hook of the plug supposedly be pointed at the exhaust valve? Well, that's what I want to know. We've tried indexing plugs primarily on the dyno for getting them out of the way of dome design so that the spark plug doesn't hit the dome. And Brule has tested indexing and hasn't shown any power gain, but I still want to test it. Open end to the intake valve. I think that that's generally what people think works. On flatheads, maybe. Yeah, Salvador, you put plug wires on your 3800 and it felt better. I've changed the oil in my car and it felt better. I just want it to be, I want it to be something because I put good oil in it, Arco graphite back in the day. Uncle Tony says put pistons in backwards for more power. Yep. Was impressed with the gap testing and that there was a measurable effect back that day. We spent a good amount of time cutting back and squaring round edges, electrodes, all of that stuff. Yep. If the data is good enough for Brule, it's good enough for me. I still want to try it on. I don't know what specific engine he tried that on, and I'd like to talk to him about it and find out if we could go back and look at the data. He's not going to remember exactly what it was, probably, because when you run hundreds and hundreds and hundreds of probably thousands now. Well, I'd like to go back and look at that data and see, and I'd like to test it. Actually, I'd like to test it with Brule because he's very good at making sure everything is 100% repeatable. I like the way that he does testing. And so I'd like to run that. We'd like to have oil temperature, water temperature, and all that stuff to make sure that all that is exact. The way that we did when we did the piston flip test is a perfect example of that. We got it so that the motor was, and that's a test that I did with the guys from Engine Masters. I sat in for Steve. And when we did that test, we got the repeatability to within the right side of the decimal point, as you're looking at it, to be within less than a few tenths of a horsepower. So we could get that thing to be that repeatable, and that's really hard to do because the motor itself is maybe from one run to another is maybe not that repeatable, but it was, which is really saying something for a junkyard piece of junk motor. And then to do the piston flip and then have the thing show nothing to, when you're looking at the other side of the decimal point for your changes, that's not anything. The only time I've seen people worry about indexing plugs is when they have pop-up pistons. That's what we were doing. We had to do it on I remember specifically on the DZ302 because it has a big dome being only 300 inches to get 11-to-1 with the fuely heads, the 64cc chamber heads. It has to have a pretty big dome on it, much, bigger than the 327 and obviously a lot bigger than the 350, which they rely on displacement, obviously, to add some compression. So that dome was really big. So we had to notch the dome a little bit and then orient the plug. And this was especially the case after we took the stock head off and put airflow research heads on. So when we did that, we definitely had to be mindful of it. I've been running E3 plugs, no gap, same for the pulsars. I have my daily driver. If we're going down the plug gap road, should we test different plug wire sizes, 10 millimeters? I honestly think you're going to be hard pressed to beat a factory LS plug wire, but it's always worth testing. The thinking was that the open to exhaust intake charge would cool the tip and run the timing on the ragged edge. And that's assuming that timing does anything. So when we run our testing, we advance the timing until it doesn't make any more power. And then there's no more power to be had from timing, but yet I will get people. I got comments like this already. I'll get people to say, "Oh, you need to throw some timing at her." Okay, but we already did that. We added timing until it stopped making power. More timing. Oh no, you got to come on. You got to throw some timing at it. They love timing. No, it only likes a certain amount of timing, and then more timing is bad. It will stop making power, and then it'll start losing power, and then it'll start losing parts. That's what happens. What's your favorite book on the shelf? I have lots of them up there that I've read for different reasons. Wrong side of the decimal point. That's right. Woody's Nova, you just got home from the hospital. Hopefully everything is okay. Picking the right plug and heat range. What is the right plug? I want to know what that is. And the right heat range. Heat range is another thing that I'd like to try. Although I think if we go from a 6 to a 7 to an 8 to a 9 to a 10, especially on a naturally aspirated motor, I don't think you're going to see anything. I don't think you're going to see anything on a boosted motor either if you don't have misfire and you aren't near the detonation threshold, which would become more critical for the heat range of the plug. You know, the heat range of the plug maybe could save you, 1% and then swing it over into the safe zone. It's not going to change the thing from detonating to not detonating if the timing is wrong or the air fuel is wrong, or you have lots of temperature in the motor. I was told long ago to after gap to round the tips. Timing for horsepower and jetting for torque. I don't think you separate those two. Granted, Shelley had a video with the dyno adding like 5 to 10 horsepower before and after, but they didn't really say if it kept timing and air fuel the same. I guess as they went stock tuned to the OEM and then retuned it. So first of all, the difference between 5 and 10 horsepower would be a lot. So as we saw here, we were searching for 1 or 2. And so that becomes difficult. The difference between 2 and 10 is a lot. Even the difference between 5 and 10 is a lot. But I don't know how you get that from something like plug wires. I'd like to see the claims that MGK makes about the ruthenium plugs. Right plug, non-resistor versus resistor. That's another thing, is resistor versus non-resistor plugs would be interesting. Take the edge off the electrode and ground. Does indexing really make noticeable power? Just does a seam responsive? I can't tell you the seam responsive part. I can only tell you what the dyno tells us. I've done spark plug indexing before, but not for power, but because I had clearance issues. Yeah, that's more common. So let's see how our poll is doing. We're 71%. Who says no to indexing plug tests? What kind of people are you guys? I like the fact that there are 76 votes and there's 79 people, but it just jumped up. So almost everybody's voting. That's good. That's good. That's good for the morning. There's a lot of good information on the internet for guys that are interested in how do you determine the different heat range of a plug, what it looks like, what projected tips look like, what different electrodes look like. If you go do a search, that's the great thing about the internet. The bad thing about the internet is all the negativity and opinionated expression on there. But the good part is there's lots of good information. If you just go, hey, look, I'm going to do a search for reading spark plugs. So you go and search for reading spark plugs. It will tell you, hey, look, this ground strap, this mark will be here. If you look down at the tip, here's how to tell whether it's getting detonation. Here's how to tell the air fuel. There's lots of really good stuff out there. Yeah, but only 35 likes. That's right, Kevin. Everybody let's get your like game going, huh? You need to step up your game on the likes. Peace. Should indexing be faced toward the exhaust or the intake or the middle? That's what we want to test. if there is a difference, did it like one of those over the others? And if there's no difference, then it doesn't really matter. My RX-8 had no strap on the spark plug, none, zero. So it's just a side gap then. Have you ever seen the aviation plugs where the electrode goes all the way around the plug? I don't think I have. We've seen the ones that you know, they're bridges and cross bridges and like the E3, you know, weird designs that they put up there. This LAS built small block Ford started with a non-resistor and an 8 heat range. Plugs were blackish, changed to resistor plug and a 5 heat range. Seemed better. Good. Have you done a video of 5.3 liter NSR truck Norris cam? Yeah, that video is already up. Not a 5.3. We did it on a 4.8. I did test the 5.3 NSR cam versus the standard truck Norris cam on a 5.3, and that video will go up soon. I wonder if indexing is more important on a wedge-shaped chamber like a Chevy compared to a center plug and a Hemi or like a Honda. Well, a Honda and a Hemi would be dramatically different. A Honda would be a pent roof 4-valve deal where the central spark plug. The Hemi has their plug positions because the chamber design is really bad. And so they need to get flame propagation. I think they probably are doing it in, you know, in two directions so that they get their problem with the Hemi is that, especially the newer one, a little bit less so than the older one, but getting the emissions dialed in for a Hemi chambers is not easy. I can see indexing on a Chevy 348 or 409. I'd like to run one of those. For maximum effort engine, I side gap the plugs and index before we dyno, but just because buff the plating off the threads, and after 300 pulls, you have blue threads, 3 threads back, 985 auto lights. But with a oh, so you're side gapping it. Okay, so you could side gap and still index it. I was going to say, if it's a surface gap, then there's no need to index it. Off topic, sorry, LM7 Gen 4. No, you can ask any question that you want. That's why we're all here. Off topic, LM7 Gen 4 rods and pistons, fast 102 intake, ported 862s, comp 281, 289. What is the 281 cam? What is the number at 50 on that? Or what is the part number of that camshaft? Do you have the specs on the truck Norris cam you tested on the 4.8? Yeah, it's a 498 lift, and it's a 212, 220 something. They don't tell you what the exhaust duration is, and it's a 107.5 LSA. 281, 289 seems like the 459 camshaft to me. If I remember right. Let's see here. Whip out my comp cams catalog. Chrysler, Chevrolet, small block Ford, Chevrolet 396 LS. Here we go. Tri-Power Extreme. I'm guessing that that's a cathedral port cam. 281, 289. So that's a 231, 239. That is a 459 cam. So 5.3 with a 459 cam and a fast intake. I don't know how well your heads are ported, but it might get near that. It might get near 500. You're going to try indexing the plugs to see if it will helps with blowout or for power gains. I just want to see if it does anything. I don't know what you mean by blowout. I've indexing the plugs is not going to change whether the plug fires or not. Seems like pointing the plug toward the index would be more logical and quick burn. I've been running E3s on my 2.34 to my escape. You'll never have time to reach conclusive results if you start testing indexing with all other variables that can affect the results. Well, if all that we change is indexing, then that's the only thing we're changing. So it's actually pretty easy to test because we're keeping the plug the same. They're going in the same cylinder. The plug wires are all the same. The temperatures are all the same. All of that's actually fairly easy. Have you seen an aluminum Ellis block crack from power and not from other reasons? I haven't seen one crack from power that I know of that is just attributed to that. Mark, can we open a cathedral port head to rec port so I don't have to use adapters? I don't think so. I think you're going to run into water before you are able to do that. Travis, a 5.3 aluminum block is definitely stronger than an LS1, LS2, or LS3 aluminum block. And guys have seen cap movement on those, which is why they don't, almost nobody uses an LS1, LS2, or LS3 aluminum block for high horsepower stuff. So if that's the road that you're going down, you should just ask the question that you want to ask if that's it. If you want to make high horsepower, use a 5.3 aluminum block or use an iron factory block or go to an aftermarket block. Found scattering distributors a thing back when gear, backlash, breaker points, oil. Yeah, that can become a thing. I see what happens to a Mitsubishi block after overboost. It's not pretty. I don't see getting to this is like the whole Big Bang thing is getting to the limit. And I don't think I even did it on the Big Bang motors that I've done. Getting to the strength limit of the components. In this case, it's all of the stock bottom end thing, whatever the weakest thing is. So stock block, stock crank, stock rod, stock pistons. Getting to the strength limit of those, which is why I wanted to do the Big Bang, finding that without finding another problem, detonation or something. Usually when guys break these motors, they break it for something else. They didn't break it because everything was perfect and they just found the combination of cycle life and or cylinder pressure or whatever the thing is that's going to cause failure of the component. I would say 99.9% of the people don't ever get to that. That's kind of what the Big Bang showed. And the block, I think, of all of the things, especially the iron blocks, I don't think you're going to get to that before you get to the weakness of another part that's in there. Night shift. So on Ski-Doo E-Tech motors, they're direct injection and are 2 strokes, so they won't run right after 6,500 RPM without the plugs indexed. I was saying if indexing would help spark blowing out from having too much gap or a weak coil, like in a boosted application. I don't know. Are you thinking that the airflow or whatever blowing across there would lessen the ability for the plug, for the ignition or the voltage to jump the gap? Is that what you're thinking? What would happen if you chamfer and round off the edges of the plug? You actually want, it's much easier for the voltage to jump the gap if there is a sharp edge. Because what you'll see on a plug is after it keeps doing that a whole bunch of times, it will take that edge off. It actually wants a sharp edge to jump it. It doesn't want it to be rounded. 1,000 horsepower LQ9 turbo boat build, getting mixed signals on keeping factory high mileage bearings versus getting one oversized and high volume pump. I don't know why you'd want to go a thou oversize, and don't use the word thoughts when you ask a question. I didn't see that till the end. Honestly, I can't see making a few extra horsepower by indexing is worth the effort unless it's strictly a drag car in a street strip application. I can't see it. You are searching, you're going through a lot of work to get maybe minimal gains, but that's why we're testing this weird stuff, just to see if it works. We've got an 18-degree Big Chief 632. That probably is a runner. Haven't had any issues. Completely off topic, but have you seen the lunatics adding turbos to burn barrels? No, I haven't seen that. So now I have to have to look something up here. Is a burn barrel something that they put junk in that they're burning like a burn pile, but they're doing it in a barrel? They're adding a turbo to that? Here's something that confuses me. I've seen you run 26-918 springs many times with high lift cams and calculating maximum lift for these springs. They're 600. Well, but you're calculating it based on what installed height. Obviously, it worked on what we were running it on, and we didn't get into coil bind, because if we got into coil bind, that would create problems. So if it wants to be a sharp edge, would it be better to have iridium or double platinum? That's why they're doing that. That's why they're doing the tiny little tip on iridium stuff. Also on iridium stuff, they're doing the tiny little tip because iridium is very, very expensive. So that's why they're using very little of it. But yeah, a really tiny micro point should allow the voltage to jump much easier. You want a sharp edge. I've seen you using leaf blowers to stoke a burn barrel. That would make sense. I mean, that's just like the bellows on a like a coal steam engine, those kinds of things. Yes, adding wood brush, closing the barrel to run the exhaust through the turbo and blowing back into the other end, making it burn hotter. Okay, well, that's kind of cool. I'll have to check it out. I like when they make the jet engines out of them too. I think that's kind of cool. John, my engine feels better with plugs indexed toward the exhaust. I gotta go. I'm at work. My boss is giving me that look. Uh-oh. Tell me you're getting data for work. Why are you confused about how high lift cams work? Most of the cams I ran were 600 or less lift anyway. And even if they were 610, if you have 10,000s variance between that, it works fine. And 60,000s coil bind clearance is a huge amount. We would run it down to 30 or even 20. In fact, it probably would run a little better at 20 or 30. Turbos on a burn barrel. I'm going to have to check that out. In conclusion, spark plug gap isn't worth it. I just wanted to show that there wasn't big power gains available from changing spark plug gap, and that it made essentially, it was worth a little bit. It was a measurable amount, so there was something there. So you have to say there was a power gain, especially 10,000s compared to 100,000s. Now, if you have spark plug gap in the range where most people run it, there's maybe one or two or something. I have a mild cam LS2 11-1 doing 408 wheel horsepower, 98 octane. If I wanted to shoot for double, how much boost do you think it would need? If you want to double it, then you run 14.7 pounds. Although an 11-1 LS2 with a small cam in it is going to be more prone to detonation. And it will be hard to double it at 14.7 pounds on 98 octane fuel, if that is 98 octane, like in Australia or Europe or wherever, because that's basically the equivalent of our 93. So it's harder to do that because you can't run very much timing in it. What would you say is the minimum amount of clearance for coil bind? Well, if you talk to Billy Godbold, you want it pretty tight, 30,000s or less. because then you get you change the spring oscillation. Could you do EFI with gasoline in an EFI system and E85 injected with a single fogger nitrous? Yeah, that's done a lot. They use a different kind of fuel in the nitrous setup. It means that you have to have a separate fuel tank for that, but it does work. Somebody asked me a comment about that, whether I thought that that would add power, because we know that on some applications, like boosted applications, we get power from E85. If you switch from gas to E85, with no change in timing, you're going to get a gain in power. Now you can add more timing because of the E85, the cooling properties, the octane. Now you can add more timing and get even more power. I personally haven't seen big changes from E85 on NA motors. There are some that seem to respond to it, but like if I run a junkyard LS on gas and then run it on E85, we don't get hardly any power change. If I run it with a turbo and I do that same test, you get a big change even before I change the timing. On a supercharged one, same thing. I don't think that you'll see a big jump in power doing that way if you run nitrous and E85 versus running nitrous and gas, because the amount of gain that you get on an NA motor is not very much anyway. The amount of E85 that you're adding to the equation is very small. It's like when we add nitrous as the intercooler for a turbo application. It is cooler, but you're just not very effective as a cooling agent. It's really effective as a power agent because it has lots of, super efficient octane oxygen molecules. So it definitely adds power, but it doesn't work very good as a cooler. And the same thing, we're not adding very much E85 relative to all of the gas that we're adding as the NA motor. And then we're adding a little bit of nitrous. So I wouldn't worry about the added power from the E85 in that instance. You're just getting a lot of power from the nitrous. Shop discussion on the math over TB throttle body induction tube size, that the smaller 75 millimeter made more gain than the 102 millimeter is bigger, better reference. I don't really understand your question. I don't know what you're asking there. I can donate an NX fuel cell single fogger system for testing. We can arrange that. That's an easy thing for us to do on the dyno. The running nitrous and EFI together is going to see a big change in power from just the nitrous, regardless of what fuel you're adding. And the little bit of E85 that you would add is probably not going to change the power very much, if at all. Richard, have you tested octane boosters? No, because the way to test octane booster, we've used them. I've used the Lucas Oil stuff. We've thrown octane booster in pump gas just as a hedge, making us feel better more than anything else. But the way to test it is you need to bring the thing into detonation, and we don't do that on the engine dyno. Joe, measuring the bore on 351 Windsor that's 30 over, I'm getting 4031 to 4032. How are you measuring that? Are you actually measuring that with the bore mic, or are you measuring it with the slidey ruler thing? Because if you're measuring it with the slidey ruler thing, that's probably not that accurate. But 1 or 1,000ths is not much of a difference if that's what it actually is. And you need to be concerned more with piston to wall clearance, because that's going to be the critical thing. That bore size change, and I don't know of any machine shop that would have ever missed by that much. But measure the piston to wall, because you might have some variation in the piston too. Indexing is supposed to shield the electrode from the incoming air, charge turbulence, and prevents the spark from blowing out. Okay. Does E85 make more power on a high compression engine? It has. I have seen it make power on Coyotes, and I've seen it make power on the LT engines, the direct injection stuff. Those are all fairly high compression. I don't know if it's just compression related, but I've tested it 4 times on NA motors and shown essentially nothing. Sometimes we see a little bit more power down low, in the same way that we see a change in power down low when we run the motor colder. But it doesn't seem to affect peak power that much. It's just not like when we see a gain, we'll see 25 or 30 or 35 or even 40 horsepower on a boosted application from running E85 versus gasoline. It's a big jump in power. And even running, like if we run race gas, let's say we're running 100, and so we have enough timing in it, it's making good power, and then we switch over to E85, it's going to jump up, like I said, 30, 40 horsepower. It's a lot. And we don't see anywhere near that on NA motors. Have I ever ran strapless plugs? You mean like, have we ever done side gap stuff or surface gap plugs? I haven't run those. Dial bore gauge and micrometer set. Okay. Yeah, but if it's 1,000ths, like I said, and one of the pistons has 1,000ths more piston to wall clearance, that wouldn't be a deal breaker for me because I'm junkyard. 74% saying yes, that I should test the indexing of the plugs. Oh, Dan's in the house. He's saying that indexing doesn't do anything. Plug gap matters, though. What's the maximum compression for 94 octane? My engine will be 12 to 1. Some say it won't work, but the new 632 big block from GM is 12 to 1, and it runs on 93. The static compression is not the only thing that's going to dictate your octane requirement. It's only one of many things. Air temperature, water temperature, chamber design, and camshaft is going to be a huge thing. The 632 GM motor, if the 1,000 horsepower one that you're talking about, probably has a really big camshaft in it. So the dynamic compression is down. You can run obviously lots more static compression with a really big camshaft than you can with a smaller camshaft. My dad has an Avalanche with a 5.3. It's a dual fuel, and the difference between gas and E85 is crazy. They may be adding a bunch more timing, I'm guessing, with E85. And if it's, depending on what year it is, if it's a LT motor, a direct injected 5.3 like an L83, they seem to respond to changes in that fuel type. We had a Mustang come in and swap the 102 millimeter cold air induction pipe to a smaller 75 millimeter pipe, and it made more power and torque. Why? Did the 102 millimeter, does it have a 102 millimeter throttle body on it? Did you change the throttle body size, or is just the size of the air intake? And was the air intake going into a 75 millimeter throttle body? That would be my question. More velocity through the tube. And then the question would be on the tubing size, what power output are you making versus the flow capacity of the tube? Is 102 more than you need? So you already had enough. You know, there's a lot of things going on. No, it went no to the 102 millimeter throttle body. Put a 205 210 cam in the ZG632 and tow 20,000 pounds of load at the Grapevine in the middle of summer and tell me 93 will work. Probably not. Special agents in the house. they ran E85 on the Skog-and-Dickey LV3, that would make sense. And on any forced induction thing, it would definitely be beneficial to run E85. It always works on turbo and supercharged stuff. Yeah, the grapevine is a serious thing. So is the grade coming up out of not Barstow, out of Baker. That Baker grade is really pretty serious. By indexing, are we talking about the position of the plugs? Yeah, we're talking about the position of the ground strap, essentially, relative to the air coming into the intake valve. The old priest grade on 101 when you try to bypass Highway 5. Yeah, there's lots of good ones that I went through a few of them leaving Nevada and going up like through Salt Lake City when I was going over to see the guys at the car farm. There were some good hills there too. So we're going to go ahead and close out our poll at 76% saying yes, indexing plugs. I think indexing the plugs and then also the different metal and the different plug types and that kind of stuff. I think all of that's going to be interesting. And then I think heat ranges too. Although I don't know how many different kinds of, well, I'm sure I could get, we have Denso Iridium plugs. I just need to make sure that the different plugs are the same heat ranges and then test different heat ranges of one kind of, that's a lot of spark plugs. I need a spark plug sponsor. And side gaps. We may have champion race plugs that are side gapped. I'll have to check with Brule. They had a bunch of champion stuff there. And so we'll have to see if they have that. If not, we can make our own. I'd like to try a side gap and I'd like to try a surface gap too. Although a surface gap, I think that's going to be a pretty big gap. I need to measure what the distance is between the spark plug and the center electrode. Sponsored by LKQ. Yeah, except that I have to buy all the motors. They don't even do that. You'd think that they would. Did you ever see the development engine with spark plugs built into the head gasket? I have not seen that. I know. What's with the likes, man? Come on, get the likes up. So you went by a CHP going 155 on the grapevine? 155 on the grapevine is a lot. The side gap would you'd wonder if the side gap would respond to indexing. A surface gap should not respond to indexing at all, if any of them do. So Bigfoot, you said I shouldn't test indexing. So why would you not want to see that test? You're dead to me. One of my cashiers got a ticket for going 106 down the grapevine. Ticket was $1,500 and had to appear in court. That's right, Michael. Except I think that there were two words before Germans. I think of it. Jackie Gleason. Sheriff Buford T. Justice, right? That's who it was. I also like the sheriff with Roger Moore, the the sheriff that was on the James Bond. He's in Live and Let Die, and then I think he was in Man with a Golden Gun too. Do you read spark plugs after each run? No, I don't normally do that. What is the tolerance of the dyno you use? 1 horsepower on a 450 horsepower is less than 1/4%. As I said, when we did the dyno testing, where we did the piston flip, the repeatability of the motor and the dyno and the guy doing the dyno was to the decimal point of 1 horsepower, less than 1 horsepower. So the dyno repeatability is perfect. There's no variation in the dyno. The variation that you would get would be in the thing that you're testing. The dyno tells the truth. It's everything else that lies. Two more minutes. It's morning time. I gotta go. Gotta get my videos done. How am I though? He doesn't care. He just Man with the Golden Gun. That's right. We saw a flying car, and we got to see the twist jump. What's a go-to camshaft for the LS3? It depends on what kind of power you want to make. Is it Wicked? Is it for drivability? Is it daily? What is it? What are you trying to do? Going to pressure test the cooling system. Hopefully nothing is cracked. You should do a brake-specific fuel consumption testing on the 4.8 and 5.3 at 30 to 40 horsepower. It would be useful to decide if you want to swap your truck. I'm not sure we could do that with the way that we have the fuel injection set up. What grade junk engines do you buy? Low grade, especially in the case of that poor little 4.8. That was not good. It was not even industrial grade. The biggest problem I have with using dyno numbers is it's not a direct representation of what works on the street. It was hard sometimes to explain to customers. I don't really understand that. It is an actual direct representation of what happens on the street. This motor that makes this much power will do this when you put it in a car. We know that because lots and lots of race motors go from there, go in vehicles and go run at the track. And what you go out and run at the track correlates directly to what the motor did. I'm scrolling, looking back for another comment, and I'm scrolling, and I'm not finding, and now I'm giving up. Have you tested conical valve springs? I haven't compared them to something else, but we've run them many times on other things. But the loading is different, dyno versus the street. That only matters for how you tune it. It doesn't matter for what the numbers that you get. So your super stocker guy wants to just race dynos. I don't think that's nearly as fun as watching them go down the track. But whatever the power curve does, especially in relation to the section that you're running when you're drag racing, the RPM range that you're using, that will tell you what it's going to do. Now you have to do a lot of other things, obviously, in the vehicle. You have to get it to launch, you have to get it to hook up, you have to get to transition, you have to get to shift. But that's why every form of professional motorsports uses these things, and chassis dynos and simulators and every bit of information that you gather is just one thing. But it the people that I see that want to say, oh, dynos are useless, they don't do anything, those are people that don't dyno test. So what they're saying is the thing that I do is right, and things that other people do, even though they're every form of professional motorsports, those guys are wrong. Dynos for when the weather is too bad to race. It does make it easier because it could be raining and pouring outside and you're still in there making noise. It's worse though, like when it's cold and rainy, it's okay because it's just California. It's not like it's 10 degrees or negative 10 degrees. But actually when it's hot, it's worse because when it gets, way over 100 where we're dyno testing, and then but the problem is that the water temperature gets really hot. And then if the water temperature gets too hot, then the dyno doesn't like that. It doesn't like having 100-degree water going into the dyno. It has a big tank. They're 2,500 gallon tanks, but they still have to cool the water. So they run it through. They have a big, giant, like 4 or 5 or 6 core heat exchanger with individual fans and stuff that they got from some jet propulsion's lab or something that they were doing. They were getting rid of it. And so they use that as the cooling towers. And then they run the water up through those and then vent all of that heat into the shop that's already, 100 plus degrees. So then it's also humid, and it gets the summers get pretty hot. Have you tried a solid lifter, like a solid flat tappet or a solid roller? I have run one solid roller in an LS, and I don't know that I'll ever do it again because it's not necessary for the things that I run. Do you know, Richard, do you know anybody who's ported a Honda D16 head to get rid of the swirl hump? I don't. I'm not that hip on the single cam stuff. I ran a bunch of that stuff way back for the book that I wrote, or for the couple of books that I wrote on Honda stuff. And I've owned a D16 I had a 93 Civic Si hatch, but I don't think we ever did any porting on it. Have you seen the effect of smog on horsepower? That will definitely affect the power, obviously. Dragging the big water tank down the track would be bad for dyno racing. It would be. Just said my car tune, the transmission tune is a massive part. All of that stuff is very, very important. The transitional stuff, that's why I keep telling people that I'm not a tuner. Tuning it for the street or the track is a whole different thing than me tuning for wide open throttle. Me tuning for wide open throttle is the equivalent of putting jets in the carburetor and turning the distributor. I'm doing that with a few keystrokes, which makes it a lot easier. But that's completely different than getting it working and running and having it drive around and shift and do all the things that it needs to do. Freezing motor, smashing knuckles. Yeah, all of that's bad. I mean, knuckle busters are always bad, but they seem especially worse when it's very, very cold. Nothing hurts worse than banging your knuckles on a freezing cold motor in the middle of winter, standing in a pile of snow with frozen toes. Wow, that paints a picture. The comments I love and this will be the last comment for today because we got to get going. We all have stuff to do. We have projects that we have to go get done. One of my projects is going to be to do another video and to wake Milo up. Apparently, I'm surprised he's not snoring. One of the comments I get is, and I get this for any engine family. Oh, you're just a Chevy guy, so and then therefore Chevy guys do this. So let's paint this little picture of the thing that I want to complain about. Then let's complain. You're just an LS guy. You do nothing but LS videos. Okay, there's like 1,500 videos up there. There's playlists for lots of other engine families, but you've never looked at those before you made this conclusion. And then it doesn't have to be LS. It could be all, if I do 2 Ford videos in a row, oh, you're just a Ford guy. You're just apparently a Cadillac guy or a Buick guy or a Honda guy or a Dodge guy or whatever. You're just that guy. Really? No, I'm not. Laying on the cold, wet, snowy ground under a vehicle and busting your knuckles. And it's worse. Like laying on snow is not nearly as bad as laying on like wet snow. That's worse. Has testing been done on injector timing on port ejection? Yeah, when I did the video, you'll see the video is up on. We did carburation versus batch fire versus sequential with port timing. We also did injector timing and saw no change in power when we changed injector timing. Eric was there, and I just had him sweep injector timing, and it didn't show anything. It didn't show any change in power at all. Can we get a slant 6 update? Yeah, it's still sitting in the same spot with the head off. Church, after 20 years, people tell me I'm just a Honda guy. Exactly. Internal combustion engine guy. That's right. Although I'm not opposed to running an electric motor and putting a Kenny Bell boost pump on it, which I was so happy when I did that with back when my son was little, on his little Power Wheels, putting the Kenny Bell booster pump on it and having him be able to have more voltage. That was cool too, because it spun the tires harder, which was nothing but good. Steam engines. A steam engine would be cool too. I like looking at the old steam engines that are operating. I like looking at the external combustion engines. All of that's good. See, external combustion. Oh, that's good. And on that note, Milo and I have stuff to do, huh, Milo? Apparently he's doing what he needs to do. I kind of wish I had his job. Thank you guys all for showing up. As always, joining me in the morning for your project motivation morning. So make sure to go get something done today. And then I will see you guys all tonight after I post another video. Pow. And Powzilla.